Hi, hello everyone, I'm Scott Phelps, and I work for a company called Millennial Media. We do mobile advertising, and me and a group of my peers, we were hired to work for them to automate their entire value pipeline. So the goal is to automate deployment from R&D all the way into production in a controlled and predictable way. So we do that using a variety of tools and technologies. And of course, we've chosen Puppet as our tool for automating the state of our machines. And we try to do that in a continuous deployment fashion. And we use Hiera data as our external node classifier. So what I'm going to talk about today is, of course, Hiera data. And I'm going to talk about putting your roles in Hiera data. And I'm going to talk about using roles as a layer of abstraction for business, using profiles as a layer of abstraction for your roles as well as your modules and the business logic as well. So we'll be talking about that. And then we'll talk about testing. I'll go into RSpec Puppet and show some examples on that, as well as Beaker, which is used for, it's a nice tool by Puppet Labs for doing some additional acceptance testing. And then lastly, I'll talk about how we tie all that in with TeamCity, which is our continuous integration tool. Some of you may use Jenkins or Travis or many of the other ones that are out there. And it has some nice features that we use on a daily basis. And then last, we'll follow up with some questions. So Hiera data. So with Hiera data, it's very trivial to take any factor fact and interpolate that as part of your Hiera data path. So here we can do location-based deployments, location-based parameter setting here, and so we can say for a location.yam, a location match, and all these are factor facts, by the way. And every factor fact has its own module where that fact lives and gets assigned to a machine. So there are certain modules that get applied to every machine by default from the Puppet Master. Puppet Enterprise provides a convenient grouping where you can go and say every machine, when it kickstarts, it automatically gets a certain default group that has the basic facts that it needs, like location, role, etc. So that's what those signify, is that just they're interpolated as part of the path. And the nice thing about Hiera data, as you probably already know, is that when it finds a match for a parameter, it stops there. So, and if it doesn't, it just keeps on going down the hierarchy until it finds something. And eventually it might end up in defaults here. And that's what we'll talk about next. One thing I want to touch on is that we do use YAML as our backend for all of them. It's very simple, it's easy to read, and it's easy to test as well. Then we do test our Hiera data, and I'll go into that also shortly. And then this is, we'll touch on in a few more slides. The data directory is also interpolated by environment, and that's going to play a key role when I talk about dynamic environments and how we continuously deploy our features, our module feature branches into their own directory, which are then available in turn to every agent based on that environment. So, next slide. So no defaults in modules guarantees that Hiera data is our single source of truth for all modules. If you do put defaults in your parameters, and you might notice we use the params pattern, but like I said, with a twist where everything is in Hiera, and so of course that means your module breaks if the parameter does not exist in Hiera, which is what we want. And so all those defaults will either go in a location default, or it can be a role default, or it can be any fact that you want can become a parameter setting for any one of these NTP parameters here. So it gives us very agile and elastic provisioning capability to be able to set parameters based on all of these facts. We'll go to the next slide here. Roles. So as I said, all our roles exist in Hiera, and the way we establish roles, like I said, is we use a simple module called role, here is sysrole, and all these prefixes is just something internal that we use to differentiate between the types of modules that we are creating. But as you can see, we created a class called sysrole, and it has a name which, as you can see, lives in higher data, as I'll go around the circle here. And it inherits its parameters from another class called sysroll_params, which in turn looks up its values from Hiera. Here's an example of what the Hiera structure looks like on disk. So you can see you have your defaults, your globals, your locations, which resolve to that directory path that I showed you on the previous slide here. So location roles, role, and that will be, locations, and then there will be roles, role.yaml. And here's an example of a role.yaml for, say, a controller role. That can be any kind of controller. It can be a domain controller, it can be a LDAP controller, it can be a puppet master, and then that role will have a certain list of, it'll be an array of profiles. And we do additional validation like on the array, a higher array and stuff like that in the module itself, but the profiles can be any number of profile classes. So the profiles themselves are also modules, and they will have modules that they contain, and I'll show some examples of that shortly. And like I said, all of our custom facts are just simple factor facts. This is one for a role, and all we do here is we read a special file that we create in ENC Puppet Labs Puppet role, and in there will be a string that gets set. So during the kick, what we do is we take the host name and we read a portion of that host name which has the node's role in it. And then that role that's in the host name gets written to this file as a string, which in this fact then goes and picks it up and assigns it as a custom factor fact. And then more stuff happens after that, which I'll go into. But that's just to cover sort of how we use roles, how we put them in Hiera data. And so for someone on the business side of the house, a controller means something to them, but it may not mean anything to us engineers. We want to know how the module's put together. So we'll have, well, we know one needs to have the base OS, we know this one's a Ansible master, it could be Tomcat, or whatever you want it to be. But this makes sense to engineers. This makes sense to the business people who want to, SOX compliance and stuff like that. All right, and next to profiles. So profiles is an additional layer of abstraction underneath roles. It sits in between roles and modules. And here's an example on the bottom right of the base OS module or profile, which got included back here. So the profile has the actual modules that are going to get applied, the actual classes, if you will. And that'd be NTP. And you can do additional custom stuff within here. And we do any types of customization settings, we'll do it in the profile class. And that keeps everything abstracted and clean. Roles just live as a simple array of profiles and Hiera data, and then all the actual implementation specifics happen in the profile class. And then that allows us to keep our modules very generic and very clean. So this sort of separates any of all the operations logic of how the module gets applied to a node and the actual module itself. So that's that. And then, of course, we want to test all of this stuff. There's no way to really know how a module is really ready for deployment if it hasn't been tested. You can't really deploy with confidence unless you have good tests. And it gives you that immediate rapid feedback while you're developing. I'm not saying write the test first, but at least if you're writing it hand in hand, you have that immediate feedback to know that you have good coverage, your modules responding and compiling in the way that you expect. And we found in practice that it just produces really high quality and very robust code that rarely breaks. If it does break, then we write more tests. So this is a little hard to read. So unit tests provide assurance that your module compiles. So what happens is there's a tool called, you can't see the side of this, but it's called RSpec Puppet. I'm sure you guys have heard of that. And this is an example of an RSpec test, RSpec Puppet test. And it includes a series of blocks of describing a behavior and setting certain expectations and then making sure that the actual result produces the expected output. So what happens here is in the unit test, we're not testing on a live machine. All it's doing is compiling the catalog and then comparing the results of that compiled catalog and the state of all the resources and types that you define to what you expect it to be. So I'm going to go through this really quick, just to kind of tell you what's going on for those who aren't familiar with Ruby or RSpec. So at the top here we have a spec helper. That's just another file that lives up a directory in the spec directory, and it's got some boilerplate code and some things that we do for mocking. And since we're not dealing with a real VM and real data, we're going to mock it, and that's what these contexts provide. Sorry, I can't click on any. So it's what these contexts provide a mocking environment where we can mock custom facts, which we do here. We have this CentOS facts is a sort of a shared context that we can use across all tests and all examples. And in there we just go in and we set these custom facts, and they look just like this. Location is a hash with a value of DC, hash key in DC. So that's exactly, it just merges this hash parameter into this. This is a hash as well, CentOS and Hiera data. And they live in the spec helper. So it's just a custom convenient thing that RSpec provides. And then here we get to into the sort of meat of what's going on. And so after the module's been applied and compiled, we go in and we compare the output. Did it compile successfully? Did it create the class that we defined, which is sysntp? Does it contain the package with ensure latest? As you know, when you define a package resource, you can ensure latest and are present or absent. And then it also contains a service with ensure running, and that is enabled. You can also do comparisons on strings and files to test your templates to make sure that the parameters that you set in Hiera data for that location got applied correctly, or was compiled correctly with the correct value, basically at this point. So here we're testing a file. It should have the content server, which is just a string, it's just a regex. And we're testing some content. We're testing the ownership of the file and the mode. And again, this isn't testing any real actual data. This is just testing the actual output of the catalog, the state of the catalog after it's been compiled. And so that's unit test. And that all that magic happens using, just really simply using RSpec Puppet and RSpec itself. And once we've done the unit test and we're sure that our catalog compiles and the actual Puppet code works without syntax errors, then we need a way of applying that code to an actual live running VM. Many of you probably use Vagrant, and it's a very useful tool for deploying your Puppet modules to an actual machine. And normally what you would do is you would go and then log into the VM and poke around and see, did it work right? Well, Beaker is a tool that I mentioned earlier. It's provided by Puppet Labs. And what it does is basically all that work for you. It creates a Vagrant file in the project's directory. So when you run the Beaker test, it will create a .vagrant and set up some additional directory structures. It will set up a Vagrant file. It will then Vagrant up, boot the VM. And then it will allow you to go through and do things like run shell commands inside the VM. So what we do is after we bootstrap the VM, we then go in and install Puppet. There's also a feature in Beaker that will allow you to specify what type of VM that you want to deploy, and it will automatically deploy a Puppet master using Puppet Enterprise. You just provided a tarball for Puppet Enterprise, it will just automatically deploy Puppet Enterprise and any number of agents. So you can have full-blown environment testing with a master and several agents and orchestration and see how it all works. And spin it all up, test everything, and then it'll shut it all down, which is great for continuous integration. There are ways to override some of those settings, whether if you want to leave the VM up only if the test passed, you can do that, or if it failed. Right? So either way, it's got a lot of options for how you do this testing. I know this might be a little hard to read over on the right here. This is an example of an acceptance test using Beaker. It doesn't have, I'm not showing all the boilerplate code. There's a lot of how-tos on Puppet Labs Beaker's GitHub wiki, and you can go and check out their how-tos. It tells you how to get started with setting things up. But here we're doing a We're just setting some Hiera data, and then once the machine boots up and you run your shell commands, which a lot of that happens in the helper acceptance. We're doing a lot of that boilerplate code of running commands. If the machine needs Java, for example, before it does anything else, you can do that there if you want. You just run shell, and Beaker will handle SSHing into the VM and running whatever command you specified. And then the nice thing about it is you can actually check the output of that command, such as down here, so I can use my arrow. You can check the exit code. And that one, we can't see it, but it says equals. So the first line here says it equals 2. So as you know, when a Puppet apply happens, when the first time it runs, if changes are made to a machine, it returns 2 if changes were made. The second time, we test it for idempotency and run it a second time, no changes should occur, and that exit code should be 0. So first we test, changes were made, it ran successfully, the exit code was 2. If it was 1, it failed, and the whole thing's going to abort. And then if it runs it a second time, if it's 0, then it will go on to the next step. So once it's applied the catalog to the machine, and all the nodes, all the manifests, then what we do here for these describes is we're using a tool called server spec. It's a Ruby project, it's a Ruby gem, and what that does is it does the same comparison that RSpec did to the catalog. This actually, though, goes and SSHs into the machine and literally checks to make sure that NTP is actually installed and that it is enabled with check config, for example, with CentOS. And like I'll go to, I guess it's RC something, and it will check and make sure that it's enabled to start on boot, and it will make sure that it's running. You can specify certain custom parameters to kind of say, okay, well, run this command and check the process table to see if it's running. So you can modify it how you like, but it will check and see if it's running, it will check and see if it's listening on the port that you expect it to. And so all these expectations give the assurance that, hey, my module applied, the service is running, the port's open, you can check file ownership, literally like all the stuff that you can check in RSpec Puppet, you can check in Beaker. It may seem redundant at first, but it's very, very useful because it tests things in a slightly different way. And it's always those slight little differences of running code on an actual machine that get you a lot of times. So it's very useful, and it does make for very robust modules. Continuous integration. So wouldn't it be nice to run all of these tests automatically? Then we can do things like this. So when we submit a pull request, say we're working on a Puppet module, we have a new feature, we're going to set up some symlinks. We're done with that feature, and now we want to push it up to our team's repo. We'll submit a pull request, and TeamCity has a feature for GitHub notification that will automatically build any pull request as soon as they're submitted. And we'll throw this message up to anybody who's looking at the pull request that TeamCity is currently building it. And then when the build is complete, it will report it'll stay yellow if it fails and tell you the exit code and give you a link to the build. If it succeeds, it'll turn green and say that you can merge with confidence. Whoever's reviewing the pull request. So that's a nice feature. It also allows you to do automatic merging and promotion of branches. So one thing that we do is we do regression testing. And when a feature branch is passed, we allow TeamCity to automatically merge that feature into regression. So that way everybody so that way all of our tests, all of our scope tests run in regression, and then we can flesh out any merge conflicts and things like that in there before we submit our module up to the release candidate status and then ultimately to gold master. So that's that. So this is sort of the workflow, how it worked for automated deployment. So that's another thing that doing testing and doing automated testing with some type of continuous integration gives you is the ability to automatically deploy your Puppet module, which is what this talk is all about. And the way it starts is TeamCity, your continuous integration server will build your module, run your test. If all your tests pass, then it will run R10K. So R10K is a tool that uses the Puppet file. Puppet file it comes from Librarian Puppet, which it will allow you to resolve module dependencies. And so if you have a module and you have Librarian Puppet installed, you can create a file called Puppet file, couple slides up. Boy, it's huge. But it looks like this. And it has a list of modules, where to get them from. If you don't specify a get and a ref, it will just automatically look to the forge and grab it. So, for example, standard lib, we brought that internally. I'm using my GitHub account, but any modules that we depend on for continuous integration and for building, we always bring those into our own personal, our own private GitHub repo, because GitHub goes down sometimes. And so that's what a Puppet file looks like. R10K, it was written as a way of, it leveraged the Puppet file that Librarian Puppet uses, and the guy that wrote it sort of just reverse engineered it, and so they could use the same Puppet file. And what you need to do is you have a repo. Let's see, do I have that up here? No. No, that's not it. All right, well, you'll have a repo. For example, this one's called Puppet Deploy, and you'll have, the only thing that will exist in there is a Puppet file. And in this repo, you're going to have all the branches that you want to deploy to your Puppet master. So branch A, branch B, whatever. So once this repo is created, you then tell R10K where that repo lives. And there's a configuration file like r10k.yaml that lives in etc. And when you run r10k deploy, it will then go and look in that repo, in our case it's Puppet deploy, pull down the Puppet file, parse it, and for each branch that exists, it will read the Puppet file and deploy the modules in that branch with the ref that you specify. So version A for module role will get deployed in branch A into this directory. So it'll look like this on the Puppet master. You'll have etc Puppet Labs Puppet, branch A, you're going to have a higher data directory with all the higher data for that feature branch. And then you'll have all your modules that were specified in the Puppet file that get deployed in there. And so then when the agent kicks off and says Puppet agent with environment branch A, any name you want, then the Puppet master is going to look in here and serve up the higher data and the modules specific for that branch to that agent. So that's how that works. Here's the Puppet file, and that's pretty much it. It creates a new environment for each branch, and again, it's just literally it's a directory on the file system that gets read right here. That becomes branch A. So that was 24 minutes. I have nothing left to talk about. But I figured I'd leave a lot of room. This is a little bit more of an advanced topic, and I figured I'd leave a lot extra time for questions if anybody had any. I was kind of expecting some.
Take the microphones up there with you.
Yes. There you go. Sure.
Two questions. One, where are you storing your Hiera data so that it's getting copied out with your branches when you create those in some repo?
That's also in Git. So we store higher data in its own Git repo, and it'll have the same directory. So we'll have all the YAML files, and then in our higher data, we also have our spec test. And all it is we wrote a little Ruby YAML that imports the YAML, and then if it doesn't import successfully, it reports the error, which will report the name of the file and the line number. And so then we'll get in our RSpec test for higher data, and that's how we also deploy that and deploy features. So whenever we create a new feature, let's say for sysntp, we have feature foo. Then we need to go into higher data and create feature foo. And so when we do a pull request, since Team City automatically builds that pull request, we have to submit the pull request for higher data, let that build, the pull request goes green, gets accepted, then we can submit our feature for the module, which depends on that higher data, because it's going to pull it down from GitHub after it's been merged.
So let's say you had your Puppet deploy repo. When you create a new branch in there, you have to create a parallel branch in your Hiera data repo so that they line up for the R10K deploy?
Right, there will be. And then each branch is going to have its own Puppet file with the list of modules, the location, and the ref that you want deployed in that environment.
So I'll lead off with my obligatory Windows question. I mean, just how, like, do you use this kind of automation with Windows systems, and do you find that works well?
No, we don't use Windows at all. We're lucky.
Some of us are
Go ahead.
lucky.
Yeah, sorry, I cannot answer any Windows questions. It's been a long time since I touched a Windows box.
That's fine. So the other question I have is, you talked about being able to, kind of orchestrate a bunch of different systems all coming up, talking to each other, running regression tests, stuff like that. Do you have some kind of, I guess, high, medium, and low numbers for like how many servers you have personally involved in some of those things, and like how long these acceptance tests take to run?
Oh, they can run like, some of the acceptance tests. So for the big modules, we've seen like the complete from running the unit test. Well, first it's got to install all the gems. So we have a gem file in each repo, and then we've got a rake file. And so then rake, the first thing that Team City, our continuous integration server, does is run a bundle. So it runs bundler, and bundle installs all the gems. Then it will go through and run the rake, and rake will then kick off all the boilerplate stuff that we need to set up fixtures. So we have in the spec directory we create fixtures, and then for the unit test you actually have to copy all of the fixtures into a directory and then point our spec to it. So for the unit test you kind of have to mock everything. But I guess 13 minutes is one of the longer ones that we see for everything from kicking off the VM, running all the tests, shutting it down, and reporting the results. It's not terrible, but you definitely need a lot of builders if you're doing a lot of like parallel development.
Sorry,
So the fact that you create with the role fact, and do you after you decide like your naming convention for your nodes, do you just put the node name in that file and then do some type of regex lookup to determine the role? Is that how that works?
So all right, no. So all right, what we
Like how do you determine what the node
for classifying the node?
Yes.
Yeah, that's a good question. I only lightly commented on that subject. So what we do is when we kick a node and the node kick starts from bare metal, the host name has the role name embedded in the host name. So it could be like something dash role dash something else, and then that role name in the kickstart. All we do is we look up the host name because we know the host name at kick and the IP address and everything else about the node. So when we kick the machine, there's just a stupid sed script that reads the host name and writes the file. So it's not fancy. And then once the Puppet agent runs for the first time after the machine's kicked, it reboots, and then we put a special first boot init script in there that kicks off a Puppet run. So the first time Puppet runs, it's going to have its role fact already available. So it's going to have a role, it's going to have a location fact, it's going to have an environment, and then the Puppet master is able to resolve everything else and assign the correct classes and modules to that node based on the profiles that we included in the role hierarchy and YAML. Does that make sense?
Yeah.
Okay, cool.
I was going to ask, what's the advantage of using R10K over Librarian?
So because Librarian will only install the modules and the dependencies into a directory. So you can give it a directory and it will install it into that directory. R10K will actually go and grab all of the branches and install the branches as environment. So it sets up those environment directories for you. And then when those environment directories are created, because we specify the path to our environments and our Puppet comp, Puppet master knows where to look and resolve the modules. So it's going to serve up the modules based on the environment, which is interpolated in the Puppet comp. So that's the advantage, is that you get dynamic environments based on the feature branches. Yeah.
So with R10K, you have to have one branch per environment, am I understanding that correctly?
Yes. Yes. Yeah. I think there was one up here too. This gentleman had a question.
It's kind of a silly question. In your profile manifest example, I noticed that the name was Top Scope. Do you just throw your profile manifests in your modules directory? Is that where you put them, or do you put them somewhere separate?
So as far as on the Puppet Master?
Yeah, I mean like directory location, basically. Yeah.
Yeah, there's a right. So under environment, there's a modules. So you can, once it's interpolated, you can give it any path you want.
Right.
But that one key component is the.
Because I wasn't sure based on the hierarchy, if you will, whether you were putting them somewhere separate, and then the name was Top Scope. So I was wondering if there was something built in that it knew where to find specific profile manifests or something like that.
Oh, so for the profile manifest, so I had. Because for the profile manifest, we just had sysntp, syslog or whatever, or something like
Well, it
that.
said base OS, specifically
Like base
profiles,
OS.
base OS one. When the examples of there's a class base OS. And then, like I said, I was just wondering if there was somewhere special, if they just went in with the rest of wherever the rest of the modules.
Yeah, they just all go, oh, I see what you're saying. So,
Yeah.
they just all go in a big pile
Okay,
in modules, yeah.
All right.
Anyone else? Excellent, well, thank you so much.
Thanks, everyone.